research is for the final product of electricity and magnetism course, with the objective of apply the knowledge gathered in this program.
This video has the purpose of explaining the propagation mechanisms on Wi-Fi on the first floor of the building 4. We focus our analysis on the access points located in the DAX offices, the marketing room, and the finance classroom.
First of all, the team had to establish a measurement campaign plan, in which we analyzed the building in order to prepare some routes to follow and achieve the desired results. We used a specialized software known as Wireless Monitor to visualize how the intensity of a signal changed as we were getting further away from the chosen access point. The team invested approximately 2 hours a day in tasks as measurements, writing the analyzed data, calculation, edition, and a preview review of every phase presented. The main propagation phenomena observed on all the building was diffraction, because most of the building consisted on walls and glass windows. Furthermore, the furniture inside the classrooms and offices, as well as the design of the building, had sharp edges. This means there was a lot of diffraction on the wave propagation. As a result of the latter, the signal on the access point was stronger near windows and open doors. Another propagation phenomenon observed was refraction. This was caused by the properties of the building materials. Dense materials, such as concrete, cause a decrement on the wave velocity and a change in its angle. This is why there was a better signal near windows than near concrete walls. Inside the classrooms, the propagation phenomenon observed was reflection. Likewise to the light, the electromagnetic waves reflected well on materials such as metal and wood. These materials were present on the classrooms, on the whiteboard, and the walls. To improve the range of the signal in the DAX offices, it is recommended to add more access points. The glass infrastructure helps the Wi-Fi to reach more spaces in the offices. However, the concrete and the non-shaped edges reduce that coverage. We suggest to implement the access point in the common area of the DAX offices, so the amplitude of the signal increases. Unfortunately, the building is not designed to install an antenna in the common area roof, due to the height of the ceiling. The best option in this case is to install a wall antenna in the DAX offices. To improve the signal in the marketing room, it is necessary to define if we want to have an omnidirectional antenna or a directional antenna. The omnidirectional antenna has more benefits for this area, because it is an open space and does not need a specific target. The glass in the cars helps the Wi-Fi not to lose too much power, and the sharp edges of the walls help to diffract the signal to more spaces.
In conclusion, Wi-Fi is a radio signal that allows communication within different devices, being a big usage of electromagnetic waves and its properties. Depending on the needs of the customer and the properties of the building, the Wi-Fi frequencies may vary between 2.4 GHz and 5 GHz, being the 2.4 most used because it has a wider range of devices that can support it and a wider range of coverage. The most effective way to install any transmitter is to analyze how the signal will emerge from it and its surroundings, identifying the main 5 propagation mechanisms and its repercussions according to the building and its location, in order to have a complete coverage of the zone.